Hello, this is Andrea Hendricks. The objective of this lesson is to show you how to graph functions of the form y is equal to sine bx and y is equal to cosine bx and identify the changes to the basic sine and cosine functions. And you might recall that when you have a transformation y is equal to f of bx, that b implies a horizontal stretching or shrinking to the original graph of y is equal to f of x. And let me illustrate that here with this flash applet that I have. On the graph we have drawn is just a basic graph of y is equal to sine of x. Notice that the period of y is equal to sine x is 2 pi, and 2 pi is roughly 6.28, so it completes one cycle of sine from 0 to 2 pi. So what happens if all I want to do is change the value of b? So I'm going to keep my a and c at 1 and 0, and I just want to change the value of b. So let's increase the b by 1 unit. So now you're looking at the graph of y is equal to sine of 2x. Well, what happened there? Well, in between my original period of 0 and 2 pi, how many cycles of sine do I have now? Here's one cycle and 2 cycles. What happens if I look at sine of 3x? Now how many cycles of sine do I have? So here's 1, 2, 3. So do you see what this number is doing? If this coefficient is greater than 1, my graph is going through the cycle of sine much more quickly, right? It doesn't take as long for it to complete a full cycle. So keep that in mind. If I take that up to 4, notice it is completing 4 cycles of sine in between 0 and 2 pi. Now let's go back down to some negative values. So let's look at here the graph of just sine x. Let me take it down to negative 1. Well, do you remember sine is an odd function? So sine of negative x is the same thing as the opposite of sine x. So anytime we see a negative inside parentheses with x, we can actually bring that out, and that would then imply that we have a reflection of that basic sine graph. So if you have a negative inside, you're not only going to see a horizontal change, but you might also see, or will also see, a reflection across the x-axis. So if we have a negative 2x, for instance, you see that the graph is a reflection across the x-axis, and then you're going to see 2 full cycles of sine in that original period of 2 pi. Now let's look at the graph of cosine, and let me get it recentered to my original function of cosine of x. Okay, so cosine has one complete period from 0 to 2 pi. If I increase my b by 1, it does the same thing, right? I'm now seeing 2 full cycles of cosine in that original period of 2 pi. If I increase it again, I see 3 cycles. Here's 1 cycle, 2 cycles, 3 cycles. I can go all the way up to 4 or 5. It can keep going, and you see the graph is continuing to go through many more cycles of sine within that original 2 pi units. Now if I decrease these values of b, let me go back to my original function. Okay, now let's look at what happens with cosine of negative x. Well, cosine of negative x is the same thing as cosine x, and that is because cosine is an even function. So if you have a negative inside parentheses, then that's really, you can ignore it, because cosine of negative x is the same thing as cosine of x. So cosine of negative x is not going to reflect it at all. It's just going to do the same change as the cosine of bx. If I continue, it's going to tell me the number of cycles that I complete in that original 2 pi units. So let me sum it up in this way. This can be said for sine x or cosine. I just have sine written here, but it's also true for cosine x. Y is equal to sine x completes one cycle from x equals 0 to x equals 2 pi. But whenever we change that to y is equal to sine of bx, it's going to complete one cycle from x equals 0 to x equals 2 pi over b, right? Because we're fitting in more than the one cycle in that 0 to 2 pi units. So b actually tells me the number of cycles of sine or cosine that's in the original period. So if the value there is 2, you're going to notice that the graph has 2 complete cycles of sine or cosine in that original period of 2 pi. Now let's look at what the period then is. So the period we can write as 2 pi divided by b. So 2 pi over b is the period of sine of bx or cosine of bx. Now, how are we going to actually apply that to graphing? So let me illustrate that with a sine graph and then a cosine graph. If we want to graph y is equal to sine of 2x, so what we need to think about now is what is the period of sine of 2x. You should know just from what we've been talking about that sine of 2x is going to complete 2 cycles of the sine curve in 0 to 2 pi units. So the period is 2 pi, which is the original period of sine, divided by this coefficient of x, which is 2. And that hopefully makes sense. If we're going to complete 2 cycles in 2 pi units, that means we're going to complete 1 cycle in half the time, which is pi units. Now, once you know the period, then what you want to do is think about those key points that are on the graph of sine. Sine normally looks like this, right? It starts at a 0, goes up, down, and back up. So at its beginning, middle, and ending point, it reaches a 0, and then between the zeros it reaches a maximum and minimum. So we need to reflect that on the graph in just pi units. So in pi units we've got to make this complete cycle. So that would mean our beginning point is at 0, the ending point of the cycle is at pi. We know in between the 2 zeros it reaches another 0. And then in between 0 and pi over 2 it reaches its maximum. And in between pi over 2 and pi it reaches its minimum. And so it reaches one complete cycle in pi units. Okay. And I could repeat that if I wanted. It's going to complete another cycle in another pi units. And my graph is hard to draw here with this graphing tablet, but hopefully you'll bear with me. So if I wanted to do this, it could go in the negative direction as well. Okay. Now let me show you on the graphing calculator how you could confirm that. I entered sine of 2x, and in my window I entered negative 2 pi for my x min, 2 pi for my x max, and a scale of pi over 4. And my y min and y max I just set to be negative 2 and 2. So every tick mark on the x-axis represents pi over 4 units. So I've started counting those off here. 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi. So you see that between 0 and pi it makes one complete cycle of the sine curve. And then another cycle is completed in 2 pi units. Now I've also illustrated here the graph of sine of 2x and sine x on the same coordinate system to illustrate this. Sine x is in bold, so sine x is completed in 2 pi units, and so we can see here on top of it that sine 2x completes 2 cycles in the same time that sine x completes 1 cycle. So just for emphasis there. Now let's look at what happens if we have a fraction. Well, that means that we have really cosine of what? If cosine of x over 2 is the same thing as cosine of 1/2 x. So my value of b is 1/2. So what that should mean to you is this, that it's only going to complete half of a cycle of cosine in the time of that original period of 2 pi units. Okay? So what is our period of cosine of x over 2? Well, the period is defined to be 2 pi over b. Well, b in this case is 1/2. So 2 pi divided by 1/2 is the same thing as 2 pi times 2 over 1, which is 4 pi. So now it's going to take 4 pi units for it to take or complete one complete cycle of cosine. Well, let's think about the way cosine looks. Cosine starts up and then it ends up, right? So it starts at a maximum, ends at a maximum, and its middle point is a minimum, and in between there are zeros. Okay? So the way we need to replicate that on our graph is this. At cosine of 0, right, if we input 0 over 2, we get 1. Well, then where does this cycle end? Well, it ends at 4 pi units. So at 4 pi units, we're also going to have 1. At 2 pi units, which is halfway between 0 and 4 pi, it's going to reach its minimum, which is -1. And then in between those points, it's going to reach its zeros. So at pi and 3 pi, we have zeros. So the cycle, when we draw it on the graph, is going to look like this. Okay. So notice that between 0 and 2 pi, it only completed half of the cycle of the cosine curve. And you could certainly extend that in the negative direction as well. So do you see what I'm doing? Once I know the period, I'm thinking of that basic shape of sine or cosine. Go ahead and get what happens at the ending points of that period, the beginning and the end, what happens in the midpoint of the period, and then what happens at the midpoints of those two things. So really you're looking at the quarter points, if you will. Now on the graphing calculator we can do this as well. If I enter cosine of x over 2, and this time I knew what my period was, so I put in a -4 pi and a 4 pi and 1.57 pi over 2 is what I used there. Okay. So you can see at 0 and at 4 pi and at 2 pi and at pi, right? Because this is 0 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. Okay? And then I also illustrated the cosine of x over 2 on top of cosine x. So cosine x is in bold. So here's cosine of x, and here is our cosine of x over 2. So you can see that it completes only half of a cycle by the time cosine of x completes one full cycle. Okay, because there's 0, and here is 2 pi, and here is 4 pi. Okay, so if you have any questions on how to graph cosine or sine of bx, please don't hesitate to contact me. Thanks.